Hi students, in this video we need to talk about dilutions. So how do we lower the concentration of our stock solution? So dilution is defined as the process by which more solvent is added to a solution in order to lower the concentration of the solute. And the equation that we use to figure out different parts, like the second concentration or the second final volume, is C1V1 equals C2V2, where C is the concentration and V is the volume. Now, the concentration can be in any of the concentration units that we've talked about so far. We can have molarity, percent M over V, percent M over M, percent V over V, etc. And if we look at this equation, we can see that one side of the equation needs to equal the other side of the equation. So say we have the solution on the right over here, and we have a concentration of 5 molar and we have 3 milliliters of this stuff. I just made that up. What we need to do is we need to have something that equals 3 times 5 on the other side of the equation. So if we have C1 is 5 milliliters and V1 is 3 milliliters, say we want to dilute this to 3 molar, then that side of the equation is going to need to equal this side of the equation. So it should be pretty obvious to you guys that we're going to have 5 milliliters there for V2. So that is C2 and that is V2. And if we look down here at these pictures, we can see that when we dilute something, we're going to have a lower concentration of our solute molecules, which are the little red triangles there, and a whole lot more of our solvent molecules. And the solvent is usually water unless stated otherwise. Now, how do we do a dilution? Well, we're going to have a concentrated solution, and quite often it's called our stock solution. And the stock solution is going to have a known concentration. So maybe we have something like 3 molar or 1 molar or 6 molar. And we want to figure out how much of our concentrated solution that we want. So maybe we want 250 milliliters, or we want 500 milliliters, or we want a whole liter. And then we're going to find a volumetric flask that has that final volume. So say we want a volumetric flask that's 250 milliliters because we want our final volume to be 250 milliliters. We'll go into the stockroom and we'll find one of those. And it has a little mark right there. And when the meniscus hits that mark, we know that we've got 250 milliliters in for our final volume. Now we're going to do a calculation and we're going to figure out how much of our concentrated solution that we need. So we would be calculating V1, and we're going to suck this up into a volumetric pipette. And what we usually have on the top of the pipette is a pipette pump. So it goes on the top like that, and it has this little knobby thing on the top, and then it has this little roller thing right here, and you use your thumb and you roll it in one direction, and this little knob on the top, it comes up and the stock solution gets sucked up into the volumetric pipette to a certain mark. And then what we're going to do is we're going to transfer this into the empty volumetric flask. So you can see that picture right here. So we're putting a certain amount in there, and how you do that is the pump, it will still be on the top up here, and what you do is you press down on that little dial right there on the top, the little knobby thing, or you roll the little roller thing in the other direction and it dispenses the stock solution. And then what we do into this flask right here is we put DI water and we fill it up to the mark right there, and then that should give us the dilute solution. So this is the original stock solution right here. And then we've got our dilute solution at the volume and whatever concentration we wanted to dilute it to. So that's the process that we use. So now we have some problems here to work. So Joan has 50 milliliters of a 0.498 molar glucose solution. She'd like to dilute this to 0.250 molar, and we want to know what her final volume would be. So this is a dilution problem, so we're going to go ahead and say, okay, I need C1 V1 equals C2 V2, and we're going to list our variables so we can organize our thoughts and we can figure out which variable we're solving for. So C1, that's our original concentration, so that is 0.498 molar. And V1, what is that? That's our original volume. So she has 50 milliliters of 0.498 molar glucose solution. And she wants to dilute this to 0.250 molar. So the question is, what is the final volume that the solution is going to have if we add DI water and make it into a 0.250 molar solution? So we have to solve for V2. So we're going to have C1 V1 divided by C2. That's going to be V2. And then all we have to do is plug and chug. So C1, we've got 0.498 molar, and V1 is 50 milliliters, and C2 is 0.250 molar. And what cancels out? The molarity cancels out, and we end up with 99.6 milliliters. Okay, so what we would do is we'd take that original 50 milliliters and we would grab some DI water, and we would squirt the DI water into that original 50 milliliters until we got a final volume of 99.6 milliliters. Now, volumetric flasks don't tend to come in volumes of 99.6. They tend to come in standard volumes like 50 milliliters, 100, 200, 250, 500. So if you have a final volume like 99.6, you would probably use a different measuring device like a graduated cylinder. And graduated cylinders aren't as accurate as volumetric flasks, but if you've got a volume like that, again, your volumetric flask, these guys right here, they're not going to have a mark at 99.6, so you don't have much of a choice. Okay. So a nurse wants to prepare a 1% M over V silver nitrate solution from 24 milliliters of a 3% stock solution of silver nitrate. How much water should be added to the 24 milliliters? So we've got it. So we can organize our thoughts. Now, most students, they're going to fill in C1, V1, C2, V2 in the order that the question lists the information. So if you did 1% M over V here for the first concentration, and then you have a question mark at V1, and then you said C2 is 3% M over V, and V2 is 24 milliliters. That will be fine as long as you keep the correct sets together. So you have 24 milliliters of your 3% M over V solution. So you have to keep those as a set together and not mix them up. Now, other students will say, wait a minute, what she originally has is 3% M over V solution, and she has 24 milliliters of that. And she wants to have a final concentration of 1% M over V. So we need to know what the final volume will be. Okay. Now, that makes more sense, but as long as you keep the sets together, meaning the 3 and the 24 go together, and the 1 and the question mark go together, you'll be fine either way. So what we do is we say, okay, in this one right here, we're solving for V2, which we already solved for up there. And we have V2 is equal to C1 V1 over C2. So we just need to plug and chug. So our C1 is 3% M over V. And V1 is 24 milliliters. And we divide it by C2, which is 1% M over V. So M over V, percent M over V, that cancels out. And we have 3 times 24 divided by 1. And that's going to give us a V2 of 72 milliliters. So what we would do is we would put the original 24 milliliters of the concentrated solution into a measuring device. And even though the volumetric flask is more accurate than the graduated cylinder, volumetric flasks don't tend to come in 72 milliliter varieties. So you'd probably use a graduated cylinder. And once your 24 milliliters of your concentrated solution is in your graduated cylinder, then you would fill it up with DI water to 72 milliliters, where the meniscus hits 72.0 milliliters. Okay, so if we worked it this way, we would be solving for V1, and V1 is equal to C2 V2 over C1. And again, I'm working this one. And if we have C2 V2 over C1, what we will get is something that looks quite familiar. You see that? It's exactly the same as that up there, and it's going to give us the exact same answer. So as long as you understand what you're doing and you keep the correct numbers together in sets, you're going to be fine. Okay, so the next question says Mary has a 2.5 liter bottle of 0.989 molar sodium hydroxide solution. She would like to make 500 milliliters of a 0.755 molar sodium hydroxide solution. How will she do this? Well, this is a dilution problem, so we're going to use C1V1 equals C2V2. And then if we were just on autopilot and we're going through the motions of what we did before, we would probably do this. We would probably say 0.989 molar NaOH if you want to write it there. And then volume, 2.5 liters. And then C2, that's our second concentration, 0.755 molar. And we want 500 milliliters of this. And then you'd look at that and you'd go, wait a minute, what am I solving for? Okay, so I want you guys to not be on autopilot when you're doing these. Actually think about what you're doing. You need 500 milliliters of your dilute solution. So do you need to use the entire 2.5 liter bottle of your concentrated solution? A 2.5 liter bottle, think about that. A big bottle of soda from the grocery store, like Pepsi or 7-Up. That's 2 liters. So we don't need the entire 2.5 liter bottle of our concentrated NaOH. We need to figure out how much of that 2.5 liters that we need to use. Okay, so we have a big bottle. We've got 2.5 liters of 0.989 molar NaOH. And it's not green, but this old picture down here shows that we've got some green stuff, but we can just, play along. All right, so we've got 2.5 liters of this stuff, and we need to know how much of this concentrated solution we need to use in order to make 500 milliliters, which is half a liter. So we definitely don't need to use 2.5 liters if we only want half a liter of the dilute solution at a lower concentration of 0.755. So we want to know with our volumetric pipette, how much of this stuff do we suck up and then go ahead and put into our flask in order to dilute it and give us 500 milliliters of dilute solution. Okay, so we have that V1 is equal to C2 V2 over what? Over C1. Okay, so C2 is 0.755 molar, and V2 is 500 milliliters, and C1 is 0.989 molar. And molarity cancels out, and we're left with milliliters, which is great because we're solving for volume, and milliliters is a unit of volume. And we punch that into our calculator, and we've got 3 sig figs, 4 sig figs, and 3 sig figs, so we're going to have an answer of 3 sig figs. And what do we get? I'll let you guys go ahead and figure that one out, and we'll answer it a little bit later. Okay, bye-bye.